Today we're going to take a look at how to add or subtract radicals. But before we begin with actually adding or subtracting a radical, I want to spend just a few minutes discussing just a little bit of vocabulary. It will make the steps for solving a little bit more easier to understand. And the first is to start off with what the symbol is called. So this symbol is called our radical. A lot of times we want to call it our square root sign, but it doesn't just mean square root. It could mean a cube root, a fourth root, 12th root. It's just a radical symbol. And our radical is determined by something known as an index. Now this index is the root that we're taking. So a square root, cube root, fourth root. If I do not see a number sitting on this shelf, then we can assume it is an invisible number 2, meaning that I'm taking the square root. I'm looking for pairs of numbers in my prime factorization. If I'm looking for something other than a square root, then the number will be written. So if it's a 3, I'm looking for a cube root. If it's a 4, I'm looking for a fourth root. If it is a 12, then I'm looking for the 12th root. The index itself is going to tell me what kind of number pairs I'm looking for. Am I looking for twins, triplets, quadruplets? What exactly am I looking for? And that will help me simplify my radicals later. And then the last thing that we have is the space underneath the radical. In this area right here. This is usually what you're going to simplify, or it's what gets left behind during simplification, and this is called our radicand. So we have a radicand underneath a radical that includes an index root. So just being able to understand those words helps us to understand the 3 steps that it takes to add or subtract radicals. So the first step that we are going to be looking at is simplifying all the radicals. So before you can add and subtract, you need to have all of your radicals in the most simplest form possible, and that means breaking down your radicand and looking for twins or triplets or quadruplets. Our second step before adding or subtracting is to identify radicals that have the same index, so the same number on the shelf. All my square roots are going to end up going together, all my cube roots, but they must also have the same radicand, meaning that not only are they square roots, not only are they cube roots, but the numbers left underneath the radical sign are also going to have to match. And the last step here is to add or subtract the coefficients. So all the numbers on the outside of the radical symbol are going to be treated as coefficients, and you're going to add them up. So an example might be like 2x plus 3x is 5x. You don't have 5x squared. You don't have 6x squared. You just have 2 plus 3 is 5, and then you keep that common variable x. The same thing is going to occur when you simplify radicals. So let's take a look at our very first example. And that is 3 square roots of 27 minus 2 square roots of 12. As I look at this problem, I do not have an index. So I know that it is an invisible 2, meaning that I am looking for pairs of numbers. So I'm going to break down my 27, and it breaks down into 9 times 3. I'm going to break down my 9 into 3 times 3 times 3 gives me my 27. Since I'm looking for sets of 2 for an index of 2, I know I'm working with 2 of my 3's. My first 3 will escape my radical prison, and the second twin unfortunately doesn't make it. Now the third 3 doesn't have a partner to help it escape the radical, so it gets left behind, leaving a square root of 3. Now, just so we don't forget that we already had a coefficient of 3, I'm going to bring that down last and multiply my coefficients together. So 3 times 3 is 9, square roots of 3. So we can say that 3 square roots of 27 simplify down to 9 square roots of 3. I'm going to do the same thing for the 12. So the 12 breaks down into 3 times 4. And 4 breaks down into 2 times 2. Since I'm looking for twins, I'm going to be working with my set of 2's. One of the 2's escapes, the other one does not, and the 3 gets left behind. So the square root of 12 reduces down to 2 square roots of 3. Now I do not want to lose my coefficient of -2 from the start, so I'm going to bring it down and multiply my coefficient. So -2 times 2 is -4 square roots of 3. So step 1 is to simplify all of your radicals. Step 2 is to identify the same index and the same radicand. So I look at the numbers on the shelf. Since I don't see them, I know that they are both 2's, so my indexes match. But my radicand must also match, so notice that both of them have a square root of 3. So both my index and my radicands match, meaning that all I need to do is use my coefficients and add or subtract them. So 9 minus 4 gives me 5, and I keep my common radical as a square root of 3. Let's take a look at another one. This time I have 3 terms. So I'm going to start by simplifying each term. So 54 is broken down into, let's say, 9 and 6. 9 can be broken down into 3 times 3, and 6 can be broken down into 2 times 3. And I want to rearrange these so that all my numbers that are the same kind of get put together. And if I look at my index here is a 3, meaning that I'm looking for triplets. So I'm going to work with my group of 3's here because there are 3 of them. The first 3 will be able to escape, and the other 3's do not. And a 2 gets left behind. And so as I leave it in the radical, I want to make sure that I write my index, because if I do not write my index, then it is assumed to be a square root. And in this case, it is not a square root, it's a cube root. I don't want to forget about the 3 that was already out, so I'm going to bring it straight down. And this reduces down to 9 cube roots of 2. So this is my first term. If I take a look at my second term, I see that my radicand is already a 2, so it does not have to be simplified any farther. So I'm going to bring it straight down. Now my third term has a radicand of a -16. Now the beautiful thing about indexes are that odd indexes love the negative signs. If you have a negative radicand and an odd index, they go very well together, because an odd index can take out a negative sign without turning it into an imaginary number. So when I break down the 16, this can be broken down into 4 times 4, and both of those 4's can be broken down into 2 times 2. So I know I'm looking for triplets, and I also know I have to deal with my negative sign. And since I have an odd index, odds love the negative sign, so I'm going to make sure that my negative comes out with my 2's. So my first 2 comes out, and it's going to carry that negative sign because odd indexes love negative signs. And unfortunately, I have a 2 that's left behind. Now I don't want to lose the 7 that was originally out in front. So 7 times negative 2 gives me negative 14 cube roots of 2. So right now I have 9 cube roots of 2 minus 2 cube roots of 2 minus 14 cube roots of 2. So my second step is to identify the same index and radicands. All of these have an index of 3. All of them also have a radicand of 2, meaning that I can simplify using just the coefficients. So 9 minus 2 minus 14 is going to give me negative 7, and then I leave the common radicand. So negative 7 cube roots of 2. Let's try another one. Let's take a look at this one. Now before I get started, I can already see that I have 2 terms with a an index of 4, and 1 with an index of 3. And since I know that I cannot mix these numbers if my indexes are different, I can tell at the beginning that because my first 2 terms share the same index, there is a possibility, and only one possibility, that they can go together. We want to make sure that the only way that they can really be added or subtracted is if they not only have the same index, but when we simplify, they have the same radicand. So I'm going to start by breaking down my 48 into 6 times 8. 6 can be broken down into 3 times 2, and 8 can be broken down into 2 times 2 times 2. My index is a 4, so I'm looking for quadruplets. My first quadruplet gets to come out, the other 3 do not, and a 3 gets left behind. So I write a 4th root of 3. Now I don't want to forget about the 7 that was already in front. So 7 times 2 4th roots of 3 gives me 14, the 4th root of 3. If I look at my second term, my radicand is a 3. So I can't simplify it any farther, so I simply bring it down. Now my third term can be broken down. So 72 can be broken down into 9 times 8. 9 can be broken down into 3 times 3. And 8 can be broken down into 2 times 2 times 2. This time, instead of looking for quadruplets, my index says I'm looking for triplets. So the first 2 gets to come out, and the others do not. Then I'm left with 3 times 3, which gives me 9. Since I do not want to lose the coefficient that I originally started off with, I'm going to bring it straight down. And 3 times 2 cube roots of 9 gives me a positive 6 cube roots of 9. Step 2 says identify radicals with the same index and the same radicand. So both of these first 2 terms share a radical with an index of 4. They also have a radicand of 3, meaning that they can combine. My third term, however, only has an index of 3, and so it is unable to combine with the first 2 terms. So now I know I can work with just the coefficients, and 14 minus 2 gives me 12, 4th roots of 3. And since I can't do anything with my third term, I simply bring it down, making sure to keep my indexes and my radicands right where they're supposed to be. Let's take a look at what happens if I include variables in my radicand. For example, number 5. So not only do I have the square root of 98, but I also have x to the 4th and y squared included in my radicand. If I look at my index, I do not have a number, so I know that it is an invisible 2. The same thing in this example over here, or in my second term. So I'm going to break my 98 down. 98 is even, so I know I can take out a 2. So 2 times 49 gives me 98. And 49 can be broken down into 7 times 7. I will also have 4 x's and 2 y's because of my exponents on my variables. Since I'm looking for twins, I have a group of 7's, a group of x, another group of x, and a group of y. So when I simplify this down, it simplifies to 7 x squared, because I took 2 groups of x's out, y, times the square root of 2, because the 2 got left behind. I'm going to do the same thing to my second term. Now if I look inside, my radicand is already 2, which means that I can't simplify this any farther. So I'm going to bring the whole thing down. 3x squared y square roots of 2. Now when you have to simplify using variables, not only are we going to be looking for the same index and the same radicand, but you also have to include the same variable and the same exponent. So we want to be very careful. So 1, do they have the same variable or variables, in this case x and y? And not only do they have to have the same variables, but those variables have to share the same exponents. So for example, you cannot add an x to an x squared. So not only do you have to have the same variables, but you must also have the same exponents. 2, do they have the same index? And 3, do they have the same radicand? So if I look at these two terms, they both are taking the square root, they both have the number 2 as a radicand, and they both have x squared and y. So x squared y square root of 2 occurs in both terms. Therefore, I can treat 7 and negative 3 as a coefficient. So 7 minus 3 gives me 4 x squared y square root of 2. So for our last example, let's take a look at one that does involve both numbers and variables under the radical, but do not share the same exponents. So here I have the cube root of negative 40a to the 7th plus 2a squared times the cube root of 135a to the 4th. So I'm going to start off by simplifying my 40, and I do see that it has a negative sign. However, odd indexes love the negative. So when I break down the 40, I have 4 times 10. 4 can be broken down into 2 times 2, and 10 can be broken down into 2 times 5. Then I will have 7 A's. Now my index wants triplets, so I have the 2's, and since 40 had a negative sign, I'm also going to make sure that when I take out the 2, it has the negative as well, because odd indexes love negative signs. But I also have 2 groups of A that have 3 A's in them. So the cube root of negative 40, a to the 7th, simplifies down into negative 2a squared square root of 5a. If I come over here on the right hand side to my second term and I begin to break down 135, it doesn't end in a 5, so I know that it's got a factor of 5, so 5 times 27. If I break down my 27, it can break down into 3 times 3 times 3 with 4 a's. And I am looking for triplets. And so my radicand simplifies down to 3a cube root of 5a. But I don't want to lose the coefficient that was already there to begin with. So 2a squared times 3a gives me 6a cubed cube root of 5a. Now remember, there are 4 criteria that have to be met when working with variables. 1, do they have the same variables? Do those variables also have the same exponents? Do they have the same index? And do they have the same radicand? So here I can see that my index, I forgot to write it on that first one, but my indexes are both 3. My radicands are also 5a. They have the same variables in that they both contain a variable a. However, one of my variables is squared and the other variable is cubed, so they do not have the same exponents. Therefore, they cannot be combined, and my final answer is simply negative 2a squared cube root of 5a plus 6a cubed cube root of 5a.